Okay, good morning, everyone. So far, we've had three ways in which you could find the zeros of a quadratic function. One is by graphing, and that was sort of like the take-home test you had. All you had to do was just use decimals to find the zeros, and you were able to solve the quadratic equation. The other way is by factoring, so we've done factoring. And then the third way is by completing a square. Well, we're going to learn the final way you can solve a quadratic equation or find the zeros. And you have been introduced to this before because I saw some of you were doing this on your test, but you weren't allowed to. You had to factor, so you wouldn't have gotten credit if you used a quadratic formula. So today we're going to look at the quadratic formula. So our objective, solve quadratic equations using the quadratic formula, and then we'll classify the roots or zeros using the discriminant. So we'll figure out what the discriminant is. But here, the standard form of a quadratic function is, and I think I've talked about this before, f of x equals ax squared plus bx plus c, standard form. Okay, so then the zeros of that quadratic formula, and we could actually complete the square on ax squared plus bx plus c, and lucky you don't have to do that, but when I was in high school we did. We had to start here and then complete the square, and then we got there. Okay, so but if you completed a square on ax squared plus bx plus c, what you would get is x is equal to, and you've sang the song before, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, you can use a quadratic formula to solve any quadratic equation that is written in standard form. Again, it's important that it's written in standard form. Okay, very important that it's written in standard form, ax squared plus bx plus c. Including equations with real solutions or complex solutions. So in your homework, when you were completing the square, you got imaginary roots. Okay, those weren't real solutions, they were complex solutions. So let's take a look at an example here. So here we have a function is written in standard form, x squared plus 3x minus 7, and we'll use the quadratic formula. So I always tell students when they're using the quadratic formula to find your variable. So a is equal to 1, that's the coefficient of x squared, so that's 1, and then b is equal to 3, that's the coefficient of the x term, and then c is equal to negative 7. Okay, so we'll use the quadratic formula. Okay, so x is equal to negative b, negative 3, plus or minus the square root of b squared, 3 squared, minus 4 ac, 1 times negative 7. And let's see here, so 3 squared is 9, 3 squared is 9, and then a negative 4 times 1 times a negative 7 gives you a positive 28. And so 9 plus 28 is 37. And so we have negative 3 plus or minus the square root of 37 over 2. Certainly you would not have been able to factor that. Okay, so you would have used the quadratic formula. You could have completed the square, but as you'll see here, the quadratic formula with that one was a little easier to use than completing the square. And I'll jump ahead, and why? Well, because that b term was odd. Okay, when that b term is even, sometimes it's much easier to complete the square. All right, so you got x is equal to negative 3 plus or minus the square root of 37 over 2. Let's look at the next one here. Find the zeros. Okay, so we said x squared minus 8x plus 10 is equal to 0. I always encourage you to first try and factor. So can you think of factors of 10 that add up to negative 8? I can't. Okay, so we'll use the quadratic formula. So again here in this problem, a is equal to 1, that's the coefficient of the x, so that's the coefficient of the x squared term. And then b is equal to negative 8. And then c is equal to 10. Okay, and then we'll just plug in. So x is equal to negative 8 plus or minus the square root of negative a squared minus 4 times a times c, all over 2a, 2 times 1. So we have 8 plus or minus the square root of negative a squared is 64, and negative 4 times 1 times 10 is negative 40, all over 2, and so we get 8 plus or minus root 24 over 2, and then root 24, you can simplify that, so this is root 4 times root 6. Oh, I saw some of you on your test. Guys, in Algebra 2, and beyond, if you don't simplify your radicals, you will lose points, okay? Algebra 2 teachers and every teacher above Algebra 2 expect you to simplify radicals. So make sure you always simplify radicals or you'll lose points. So this is just equal to 2 root 6, which is what we have. So x plus or minus 2 root 6 over 2. And here I can actually, so I want you to notice here I have an 8, 2, and 2. Okay, so what's common to 8, 2, and 2? Well, it's 2. Okay, so what I could do here, so I could say 2 goes into 2 once, and to 8 4 times, and then to 2 once. So I have 4 plus or minus 1 root 6 over 1, but we don't really write the 1 over there. So, all right. So again, notice what I did. I had the 8, 2, and 2, so always simplify 8, 2, and 2. And so 2 goes into 2 once, and to 8 4 times, and then to 2 once. So 4 plus or minus root 6. Now, the thing about this one here, using quadratic formula certainly works, but, you know, we started with x squared minus 8x minus 10 equals 0. I would just go for the complete the square. I just find, because my b term here is a even, and particularly because my coefficient for x squared is 1, I would just complete the square on that. So I would have gone x squared minus 8x equals 10. Remember, you want to get the c term on the right. And then you just complete the square. So x and x, and you take that negative 8 divided by 2. Negative 8 divided by 2, that's negative 4, negative 4. So x squared minus 4x minus 4x. And there's my x squared minus 8x. And when we complete the square, we'll add 16. So we have x squared minus 8x plus 16 equals 10 plus 16. That's what we added. We added 16, right? So we have to add it to both sides. Now, over time, you don't even do all of this. So, and the easy way to recognize is this. I'll show you. So this is just x minus 4 squared equals 26. And then I get, let me do this. Oh, was that plus 10? Oh, yeah, it was plus 10. I was going to say, wait a minute. I know I was thinking ahead. I knew I wasn't going to get the right answer there. So, what I got up there before. Okay, so that's minus 10. Minus 10. All right, and so this is plus or minus. So this is 6 here. Negative 10 plus. So this is 6. There we go. That's looking better. So I was looking up here and wait a minute, something's not going to work there. Okay, so then I have to take the square root of both sides. And then that gives me x minus 4 equals plus or minus root 6, and x is equal to 4 plus or minus, root 6. Root 6. Now you see, to me, completing the square was much easier. Okay, I mean, and the thing about that, you know, when you complete the square, it's just, to me, I always say it's so easy, because all you do is you take that b term, negative 8, you divide it by 2, you stick it in the parentheses. X minus 4 squared equals negative 10. You take what's in the parentheses, negative 4, and you just add it to the right. You add it to the right. So you see, there's only like really 2 steps there, or 3. So now you have x minus 4 squared equals 6. So to me, there's only really 2 steps. Actually, there's really only one once you get the negative 10 on the right. It's just that one and that one. And to me, that's a lot quicker. That's a lot quicker than using the quadratic formula the way they do it up there. But it's entirely up to you. Okay, I know back when we had junior high school, 9th graders, boy, they loved completing the square, particularly with problems like that. Much easier to do than the quadratic formula. All right, so let's continue on. And then here's another one. So find the zeros. So again here, a is equal to 4. A is equal to 4. and then b is equal to 3, and c is equal to 2. Okay, so x is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 2. So we get 9 minus negative 32 underneath the radical. Oops, it looks like they forgot that plus or minus though, didn't they? Okay, negative 3 plus or minus the square root of negative 23 over 8. And of course, square root of negative 23, and that's just equal to I root 23. So we get, boy, they kind of skipped a lot. So this would be negative 3 plus or minus I root 23 over 8. Ooh, boy, they really... Okay, so they're writing that in complex number form. Remember, a plus bi. So a is negative 3/8, and then plus, they should write the I in front, though. I root 23 over 8. Bad. The I should be in front. Anyway, so they wrote that in complex number form. Now notice here, that would have been difficult to complete the square. Why? Well, first of all, because that's odd, and then we have that's 4. I mean, I would not have been able to factor out the 4. I could have done something like this here. And again, I'm going through this because it's important to understand. So could I factor out the 4 here? I could not, because I have the 3. I mean, it's just kind of messy. So you would not have, you could have done it, if you like working with fractions. I wouldn't have had a problem with it. I mean, but I know students generally don't like fractions. But anyway, a quadratic formula was much easier to use for that one there. Okay, and then now we come to the discriminant, the thing underneath the radical. Okay, in a quadratic formula, if I go back up here, the discriminant, right there, b squared minus 4ac. That's called the discriminant. That gives us a clue as to what type of solutions we'll have. So let's look here. So the discriminant is part of the quadratic formula that you can use to determine the number of real roots of a quadratic equation. I would say the number of roots, not just real, but also complex roots, because imaginary roots aren't real. You remember? I mean the complex number system. Complex number system. We have real numbers, and then we have imaginary. Real and imaginary, complex number system, so that you can use to determine number of complex roots. I would say complex roots. Boy, they really kind of screwed this up. Complex roots of a quadratic equation, either real or imaginary. So, if the discriminant is positive, if it's greater than 0, we'll always have 2 real roots. Somewhere they'll cross the x-axis if the discriminant is positive. If the discriminant is equal to 0, we have a perfect square trinomial. We'll have just 1 real root. But if the discriminant is negative, we'll get that pesky I, and it will never cross the x-axis. We won't have any real roots. Okay, we'll have complex solutions. More particular, we'll have imaginary roots as well. So, all right. So now let's take a look at. So be sure the equation is in standard form. Okay, before you do this, so ax squared plus bx plus c equals 0. Make sure it's in standard form always when you evaluate the discriminant. So let's look at some examples here. So here, find the type and the number of solutions for the equation x squared plus 30x, or 30 plus 12 equals, x squared plus 30 equals 12x. So again, it has to be in standard form. So x squared minus 12x plus 30 equals 0. So here a is equal to 1, b equals negative 12, and c equals 30. Okay, so again, remember the discriminant is b squared minus 4ac. Okay, so we have negative 12 minus 4 times a times c, and that gives us 24. So we'll have 2 distinct real solutions. And I could show you, I could easily complete the square on that and find them. So if I go x squared minus 12x equals negative 30, I mean, I'll show you how easy it is to complete the square on this. So here, so this just becomes, take that negative 12 divided by 2, that's 6, negative 6, negative square, and then you have negative 30. Take that negative 6 and square it, and you get 36. So now you have x minus 6 squared equals, what's that, 6? And then now you take the square root of both sides, and then you get x minus 6 equals plus or minus root 6. And there's your two real roots. No imaginary roots. Real. See how easy it is to work with the complete the square. All right, so we had two real roots. The discriminant was greater than 0. It was 24. Let's look at the next one. Find the type and the number of solutions for the equation. So again, we put it in a standard form. Here, a is equal to 1, b is equal to negative 4, and c is equal to 4. Okay, so again, the discriminant is b squared minus 4ac. So we have negative 4 squared minus 4 times a times c. So 16 minus 16, that equals 0. And that's, all right, so we just have one real root. Some of you may recognize this as a perfect square trinomial. If I factor that, that's x minus 2 times x minus 2 equals 0. I only have one 0, and that's 2. It touches the x-axis. You see, it's a perfect square trinomial. One real root. The discriminant equals 0. All right, and then let's see here. And then the last one, find the type and number of solutions for the equation. So again, we write in a standard form, x squared minus 12x plus 40. So again, here a is equal to 1, b equals negative 12, and c equals 40. And again, the discriminant is b squared minus 4ac. So we have negative 12 squared minus 4 times 1 times 40. So that's 144 minus 160. That's negative 16. So we'll have two complex solutions, imaginary roots. And again, I'll complete the square, and you'll see here how easy. So I have x squared minus 12x. I have plus 40, so equals negative 40. Move that 40 over. Okay, I'll take that negative 12 divided by 2. So this would be x minus 6, take the squared. Take negative 40, and then take that negative 6 and square that. That's 36. So now I have x minus 6 squared equals negative 4. And take the square root of that. And now I have x minus 6 equals plus or minus the square root of negative 4. Well, the square root of 4 is 2, so remember, square root of negative 4 equals square root of 4 times the square root of negative 1, which is just I root 2. I mean I2, 2i. The square root of 4 is 2, and the square root of negative 1 is I in there. So now we have x is equal to 6 plus or minus 2i. So see how easy it is to, to use the complete the square? Easy peasy. All right, so there we have two non-real roots, imaginary roots, complex solutions. All right. So and I went through this because as you guys are doing your homework, it will say, so I'll use any method to find the zeros of this quadratic equation. So use any method. Okay, if you find completing the square out of a problem like this much easier, I would. I wouldn't use the quadratic formula. I just find completing the square much easier. This one here, I could just factor. So go for it. It's easy to do. See, the important thing, you have to develop the ability to be able to factor or use any method fluently. You should be able to look at it and see exactly what to do, because I tell you, when you get to chapter 6 and beyond, that's going to be so important. I always say, okay, a student leaving Algebra 2, they should be able to factor like a madman, because trust me, you can't use, and you'll see in chapter 6, you have to factor. Sometimes you'll use the quadratic formula, but if you can't factor, okay, well, you just have to be able to factor as you move up in higher level mathematics. There's no way around it. Okay, so let's look at all the methods we have learned to use to find the zeros of a quadratic function. Graphing, you did that on your test. Remember, you had that problem, the free-falling object, and you found the roots by using decimals. That's graphing. Factoring, okay, if you can factor, go for it. C is equal to 0. Okay, if it's easy to factor, we'll factor. Okay, or square roots. Although this never really comes up. It comes up when you complete the square because eventually you get your square root. So that's square roots. Completing the square, x squared plus 6x equals 10. Yeah. Or if you had something like, if you had something like 16x squared. Here, maybe something like this. If you had something like 4x squared plus 8x equals negative 7. Again, I tell you, I'll make this a little easier. So I would just factor out that 4. So I would get x squared plus 2x equals negative 16. And then you would have x squared plus 2x equals negative 4. Right? So it doesn't necessarily have to be that a is equal to 1. Okay? Yeah, if it is, that's great. But if it's easy to factor out like that, factor out that leading coefficient, then I would do that too. So, and complete the square. And then the quadratic formula. So this would be so tough to complete the square on here. So use the quadratic formula. All right, so this is an overview. So this is it, guys. I mean, we're done with teaching you how to factor in chapter 5, and then you'll use it extensively in chapter 6, okay, and beyond. So very important to be able to factor and find the zeros. Okay.